Okay, you guys are going to be taking your unit test tomorrow. That'd be Tuesday, so make sure you get through all of this pretest and that you've studied it well. We've been going through this introduction to quadratic equations, so I think you're going to be fine with it, but let's make sure we get through this well. Here we go. So this is a practice test here. A family is building a patio onto the back of the house with a rectangular area in the center and equal square sections on both sides. The entire length of the patio can be no longer than 20 feet. Let P represent the width of each square section. So let me kind of draw this out. Hold on, I'm gonna go here and I'm gonna try and make it here in make something like that. So it is a rectangular area, right? And equal square sections on both sides. Okay, so I'm going to try to do this just real quick. Let's see if I had a segment here, and then I had perpendicular lines on the end of them here and here, right? And then let's say that I made, let's put points on those perpendicular lines somewhere. Oh boy. Let me undo that, try that again. Point on line G. And then if I were to, actually, what I should do is this. Let me undo that. Sorry about that. Undo. So if I ended up with a specific sized point, let's say that was, I don't know, 2.5 here, just for example, and then I did the same thing here, 2.5, and then what I've got is I've got the intersection points where those circles intersect that line and where this circle intersects that line. Alright, now I've got my rectangle A, B, E, C. Okay, back to A. That makes this a rectangle. Okay, by for sure then now I know I have a rectangle here. And what I have to do is I have to add a square. So, you know what I should do is I should make that into a line here instead of a segment. Let's try that. Let's try a line from here through there, and from make another one here to there, and then I will find the intersection points of this circle with that line. Okay, and I will draw a perpendicular to that line through that point, and I'll find the intersection point there. Okay, so this is the addition that we're putting on, right? Do the same thing here, make a perpendicular right there where they meet. Oh, that wasn't right. Let me get that. Let me get that intersection point again. The intersection point of this line and that circle. There we go. And now I can put a perpendicular line that goes through there. Okay, and then where those points intersect, I got the intersection tool here. Okay, so here's a square and there's a square. These two squares are the same exact size, right? And this is a rectangle with two congruent squares on the end. Okay? It says they're building a patio on the back of the house, a rectangular area in the center and equal square sections on both sides. Okay, the entire length of the patio can be no longer than 20 feet. So the patio goes onto the back, and with a rectangular area in the center and equal square sections on both sides. So the entire length can be no more than 20. And P is the width of each square. So if this is P and that is P, so let me write. I think I get a marker here I can write with. No? No, I can't. Well, actually, I don't know, but I can write with this. So here we go. So what they're saying is this length right here is P. and this length right here is P, right? And then this entire thing is 20. Because these are squares, this is also P, right? So the rectangle's area is P by, what's this length? Well, this is 20, take away 2P, right? 20 minus 2P. Now this is not easy for you to figure out. It's a word problem. It wouldn't be easy for me to figure it out. What helps is, you know, drawing it out, sketching out. You don't need to do circles and all that. You can make a sketch of this. But since I can't sketch very good, I'm just using this tool. The point is, follow through one part of this problem at a time. Okay, one part of the problem at a time is what's going to help you figure it out. I can't go back to that just yet. But I see I have 20 minus 2p here for one side. The squares are p squared, and then this whole thing is 20. So that length of that rectangle is 20 by 2p, or 20 minus 2p. Okay, I've got to go back to my other part of the problem. So it says, write an expression to represent the length of the rectangular part of the patio and the area of the rectangular part of the patio. Okay, so the rectangular part, okay, that is going to be, the length is 20 minus 2p, right? And the area is going to be p, remember we said it was p, times 20 minus 2p. Close that out. And then if I distribute that in, I'm going to get negative 2p times p, so negative 2p squared, and plus 20p, right? Plus 20p. Negative 2p squared plus 20p. Okay. So it says write the expression for the area as a function in standard form. So in standard form I'd have f. Oh, let me not use f. I'll use a for area. The area depends on p, which is the width of the p was the width of each square section. So a of p is equal to negative 2p squared plus 20p. Right? Determine the absolute maximum or minimum of this function. Well, I'm gonna plot it. That's how I'm gonna find that. But I'm gonna use f of x. So f of x is equal to negative 2x squared plus 20x, right? So here we go. F of x is equal to negative 2x squared plus 20x. Okay, let's go back to our here and get a new, don't save, and I'm going to put, I'll put f of x is equal to negative 2x squared plus 20x. And where are my special points? That's a nice little tool right there, but it gives me, it says Extremum. So guess what that is? If I zoom this out, I'm going to grab this scale right here. I think I can grab that. No. I'm going to move it. Now I can grab the scale. My y-axis, I'll shrink it down. So the extremum is C, which is your maximum. Now, remember, because A was negative in the standard form, it told me I knew this was going to have a maximum. I knew it was going to be facing down. Negative, right? Sad face, we've talked about that. Okay? My zeros. How are I going to find my zeros is factoring out that negative 2. Negative 2 and negative 2x I could factor out, and I would end up with x plus 10. Or if I just factored out the negative 2, then I would have x squared. Well, start by factoring out the negative 2. Let's do this real quick. So I have negative 2x squared plus 20x. So if I wanted to take out, let's say, negative 2 first. So negative 2 goes on the outside. And I'm going to see what's left on the inside. Well, I have x squared, right? And I have plus, and then this would be negative 2 times what is positive 20, and it would be negative 10x, right? And then I think, is there any other common factor here? Yes, the x can come out. So it could become negative 2 times x times x minus 10. This is factored form. I pulled that a out, negative 2. And I've got x and x minus 10. Okay? X and x minus 10. So these are my zeros, right? My zeros right here in factored form. What would turn this into 0 is if x was equal to 0. That would make this would be a 0 right here, right? And what would turn this into 0? Well, if x was positive 10, right? If x was positive 10, that will make the function turn into 0. So there's my zeros, 0 and 10, and you can see them marked there, okay? Calling them roots of x right there. It's another term we've never really used yet, but the root of x is often sometimes used, okay, in some math circles and classes. Okay, and we're going to go determine the absolute maximum and minimum. What does it mean in terms of the problem situation? So this maximum, what does it mean? Well, we were talking about the area. The function was to calculate the area of that rectangle, right? The rectangular deck. And the area of the rectangular deck, you know, if we had P equals 5, so if we made the size of those squares equal to 5, the width of each square is equal to 5, then the area of the deck would be equal to 50, or the area of the rectangle would be equal to 50. Okay? Alright, it says complete each table to calculate the first and second differences. Label each equation as linear or quadratic. Okay, so I'm going to pause this here. I'm going to get an actual calculator that we're going to be using so I can remind you of the steps of how to get this done. Okay, so first I'm going to put this in as a function in my calculator. That'll help me get this done real quick. So watch how that happens. I start with a new document. I say add graphs, and then in the function f1 of x equals, I'm gonna just put in this 3x minus 2. 3x minus 2. And that way I'm saying that the y-axis will be equal to the output of the function, f1 of x, right? So whatever the function calculates, that's going to be my value for y. I hit enter, and now I want to quickly fill in this table, so I'm going to go menu, table, split screen table, remember that? And I can go up here and look at what the table says the value of the function is at 0. So here we go. When x is at 0, then this would be negative 2. When it is at 1, then this would be 1. And this would be 4. And this would be 7. And this would be at 4, the function value is 10. So what are our first differences? 1 minus negative 2. Remember that to find your first differences, you go this direction. You say 1 take away negative 2. So 1 take away negative 2 is 1 plus 2, that's 3. 4 take away 1, that's 3. 7 take away 4, that's 3. And 10 take away 7, that's 3. So our first differences from this linear equation is a constant, and it's 3. Our second difference is found by subtracting these in this direction. 3 minus 3 is 0, right? And 3 minus 3 is, again, 0. And 3 minus 3 is, again, 0. So what do we see? Again, in a linear function, the first difference is going to be a constant. Second difference is going to be 0. Quadratic function is different. So what I'm going to do is I'm going to take my document again that I'm working in, and I'm going to click on the side where the graph is at. I'm going to go menu. I'm going to take out the graph for just a minute, or the table. So table, remove table, I'm going to say. Then I press Control G and go up to that function that we just had in there. It said 3x minus 2. I'm going to change that, so delete everything out and go negative 2x squared plus 1 and hit enter. Now I have a nice little parabola, but I need to fill in this table, so I'm going to go menu, table, and split screen table again. And at 0, I see the value is 1. And at 1, it's negative 1. And at 2, it's negative 7. And at 3, it is negative 17. And then at 4, it is negative 31. Okay, and now we're going to find the first differences. So negative 1 minus 1, that's negative 2. Oops, negative 2. Negative 7 minus negative 1 is negative 6. Right, negative 7 minus a negative is like plus 1, right? Negative 7 minus a negative 17 minus a negative 7 is negative 10. Negative 31 minus a negative 17 is negative 14. Because I do minus a negative, these turns into plus, right? So now I do my subtraction again and find my second differences. Notice the first difference is not a constant, but my second difference is negative 7 or negative 6. Take away negative 2. Negative 6 minus negative 2 is negative 4. So what do I find now? My second difference, negative 4, negative 10 minus negative 6, negative 4. Negative 14 minus negative 10, negative 4. So my second differences are constant, and if I did my third differences, what would it be equal to? The differences are 0. Okay, so we see a quadratic equation here that the second differences are constant, and a linear equation, the first differences are constant. And this is mostly seen as kind of a preview for something we'll talk about when you get to calculus. Okay, pretty cool. All right, here it says the graph represents the function f of x equals negative 2x squared plus 8x. So identify each of the properties listed. So now they've given us the graph. We just need to find the properties and identify them. Okay, so remember that we're going to use our interval notation, which we haven't used for a while since earlier in the class. I'll try to make sure I use it well here. And we're going to try and make sure that we've got everything documented here. So basically our domain is all real numbers, right? I mean, we can put any number in left to right. Remember, the domain is all values of x that can be put into this equation. We can put any number in for x that we want. Sometimes we use this symbol to show that the domain, we'd say, we do this sometimes, I go, the domain, I put a nice D here, is a set of all real numbers, and they use this little double R, like double line R right here. So that would mean the set of all real numbers. And actually, that's just basically saying the domain such that it's all real numbers, right? Okay, the range. Now the range is different because the range is the outputs, and we can see that we have a maximum here. So it's going to be all real numbers. So the range we'll say is the set. I should have written this like this before because it's a little bit better. You write the all real numbers first. Okay, we didn't need this part here. I probably shouldn't have written it. But then now we use this colon that we can sometimes mean such that. Right, or we put a little bar there, double bar or whatever. Set of all real numbers such that they are less than, we want those numbers to be less than or equal to 8. Okay, because we want every number that is 8 or less. It goes down forever, but it doesn't go above 8 at all. Our zeros, our first zero is at 0, 0, so we have a 0 at 0, 0. At the origin. Our next zero is right here at 4. So we have two zeros, 0 and 4. Okay. The interval of increase. So now this is when we use our interval notation. So it is increasing from infinity, right? From infinity. Notice I'm using the open parentheses. Oh, I can use interval notation here too. The entire domain goes from negative infinity. And I'm using those parentheses because we're not using infinity here as an actual number that's going to be included. but more as a concept, right? All real numbers, and so we use those open parentheses, not the square brackets, the open parentheses, right? We're not including that. And now here we're going to say the range is everything from negative infinity, all right? This is a better way to write it. And then it goes up to and includes the number 8. And to include number 8, remember we make these square brackets. Square bracket keeps 8 inside. So we're saying we're including it. The parentheses we use say don't include it. Don't include negative 8 or negative infinity, but go up to 8 and include 8 as part of the range. Okay, so our interval of increase starts at negative infinity, right? It is going up from whatever value of x you put in to negative infinity until it gets to what point? Until it gets to the number 2. But is it increasing at the number 2? No, so we're not including it, so we're going to use open parentheses. And the decrease begins at negative 2. Or I mean positive 2, sorry. Positive 2. We're not including 2, because at 2 it is not increasing or decreasing. It is capped. It is at its max. It is a maximum. And then we have it continuing to decrease. Now, just a little reminder. Actually, let me just finish this. So that goes on until we get to infinity. So there's our answer and the correct notation for that answer. Okay, and that is open parentheses. We're not including the number infinity as a number. Okay, so now if we look at what this actually is talking about, let me show you increases in green. So what we're talking about is for what values of x. So where along this x-axis can you go where if you put that value in, you're going to find that the parabola is increasing. And it turns out that's all the way right up until you hit the number 2. For any number that you put in there, okay, it's this whole area of this whole parabola for any value here that you put going back to negative infinity, that parabola would be increasing, moving right to left. And then we say decreasing. Decreasing starts here at 2, and it starts going down, and it would be a decreasing interval anywhere from that point 2 right here, and over any x's as we keep going this direction. As it gets bigger and bigger and bigger and bigger and bigger, we keep putting those x's in, and it would decrease forever. It just keeps decreasing forever. So that's the notation. We did do this in class, and you should be good at it. But in case you've forgotten, this is a review, and this is why. The range is all real numbers, which we didn't use this notation in class. So I'm sorry I went right to that and this stuff. That's not what we're using in class. We use interval notation for our domain. So the domain is going all the way from negative infinity out here to positive infinity out there. Those are all valid x inputs for this function. The range is from negative infinity down here all the way up until we get to and including the number 8. Okay, so that's where we have a square bracket. The zeros were at 0 and positive 4. Those were the two places, the two inputs, 0 and positive 4, that if we put it in, the output of the function will be 0. The interval of the increase from negative infinity increases all the way till we get to positive 2. The interval of decrease starts at 2, but then does not include 2. Everything bigger than 2 all the way out to infinity. And that is our proper notation for that. Okay. Definition, or the equation of parabola, f of x equals x squared minus 4x minus 5. The axis of symmetry is x equals 2. Determine the vertex of the parabola. Show your work. Okay, so, we can do this a couple different ways, but here's the big thing. If I know the axis of symmetry is 2, I'm going to just do this. You can do it in the calculator with the grapher, and I think you already know how to do that, and I'm not going to do that right now. I'm going to just draw this. This I know is a parabola with a positive a value, so I know that it's opening up, okay? I know the axis of symmetry goes through the vertex. The vertex in this case is going to be the minimum. So here's the axis of symmetry, and it's at x equals 2, right? So if I want to find out where that vertex is, all I have to remember is that It is the value of the function when x is equal to 2. So if I put 2 in here, like this, 2 squared, oops, if I put 2 squared, oh, that's really bad. In other words, I'm going to calculate the value of f at x equals 2. Then I would put, oh, that's so bad. I got to get a new, okay. Anyway, for the x, I'm going to put 2 squared minus 4 times 2 minus 5. Okay, 2 squared is 4. Minus 4 times 2 is 8. So 4 minus 8 minus 5. So 4 take away 8 is negative 4. Minus 5 is negative 9. So the value of the function when x is at negative 2. Oh my goodness, this is so bad. Okay, when the value of the function is when f is at negative or positive 2, then the value of the function is negative 9. So this vertex is at 2, negative 9. Okay, there we have it. 2, negative 9 would be the vertex right here. See how I figured it out? Line of symmetry is x equals 2. I know the vertex goes through it, so I put 2 into the function. Put 2 into the function here and just evaluate it. 2 squared, 4 minus 2. 4 times 2 is 8. It's negative 4. Take away 5, negative 9. Okay? All right. Let's write this next function in factored form. Writing it in factored form. So I know I've got to get rid of this a. I'm going to factor that out first. So let's see if we can do that real quick here. I'm going to pull the 4 out. So I'm going to take 4 out. And then I've got, what do I have here left? I've got x squared plus 3x okay. I don't know. I might have to just, computer is processing this so slow. And how did I get 3? Well, I divide everything inside by 4. I'm pulling 4 out, so I divide 4x squared by 4, and that leaves me x squared. 12x divided by 4 gives me 3x left, right? And then plus 8. 8 divided by 4 is 2. So that is what we call reverse distribution sometimes. It's called reverse distribution. It's basically a distribution property where we're factoring out the 4. Now I got to make a puzzle and try to figure out what times what will give me x squared plus 3x plus 2. Well, I'm using the area model we've seen and done in class before. I need this area to be equal to x squared. Okay, so that's got to be equal to x squared. And this area over here is going to have to be equal to 2. And these two are going to have to add up to 3x, right? 3x. So this is a really not going to be a very hard one for us here. Because to get to x squared, I'm going to have x here and x here. Okay, I don't know if that's going to catch up or not, but that's x times x gives me x squared. And then to get to 2, 2's a prime number, so I can put 2 here or 1 there. I could do negatives, but since this is positive and greater than the number 2, I'm going to use positive 2. I need to put positive 2 right here, right? And then I need to put positive 1. Yeah, that's not even showing up as a 2, but I'm done trying. The calculator's just, the screen writer tool is not working very well, but this will be 2x here, right? So x plus 2, x plus 1. So this will be 2x and 1 more x, so together that's 3x. So what I'm left with are these factors, x plus 2, x plus 1. So factored form would be 4 All right, that's my A value, times x plus, very bad, 2 times x plus 1. Whew. Okay, now what are my x-intercepts? Well, my x-intercepts are when the function equals to 0, so I'm going to look and say what turns these into 0, what x goes in here that would turn this into 0, and it'd have to be -2, because -2 plus 2 would be 0, right? Okay, that does not want to write a 2 for me, but I'm trying. So -2 plus 2 would be 0, and then what x would be here to turn this into 0 would be -1. So -1 would make this a 0, -2 would make this a 0, and that turned my function into 0. So I have two x-intercepts at -2 and -1. Okay. And I think right now we're going to, that post-test is, let's see, I guess I got a little bit more of this pre-test to do. But I'm going to pause this video and make a part 2. So we're going to break this into 2 parts.